uh, Continue from previous video where we solved up part A section 1. Now we are solving for part A question 2, where we need to solve by using the quadratic equations. In the previous video I explained how to get MOU, calculating the bending capacity of the beam section. So that is ASTFYD. Please note this D is not the overall depth. That D is just the one that we calculated. That D is not the whole capital D, but this is the small d that we just calculated, 738 millimeters in the previous video. So then 1 minus 0.5 alpha 2 ASYFC times ASTBD. We substitute MUO, 588 times 10 to the power 6. We calculated MUO in the previous video, where we calculated MUO from M star, which is 588 times 10 to the power 6. We need to calculate the tensile reinforcement of the Rio times FSY is 500 megapascals. As you know, we are using N24 bar, so it has a 500 megapascals. Depth is 738. We calculated depth in the first where small d is 738 millimeter, which is just from top of the bar to the middle of the reinforcement. 1 minus 0.5 alpha 2 we also calculated in the previous video. We just add up alpha to 0.802 times FSY, yield strength of the reinforcement 500, FC characteristic of concrete, it's given in the questions, which is 32 megapascals, times area of the steel reinforcement in the tensile zone of the beam, that is ESD. B is 400, is given in the questions. Width of the beam is 400 times D 738, that is the depth D from the top fiber to the tensile reinforcement small d, that is 738 millimeters. Simplifications of this whole equation, if you expand these brackets, give us this quadratic equations. Further simplification in the form of, let's say, ax square plus bx plus c equal to 0. In that format, you can use the scientific calculator or online tool to calculate the area of steel reinforcement. So it has a smaller than this value using these two methods, but still we can use these 4 bars using this steel reinforcement, which is 4 and 24 AST. Again, we can use these Rio tables, where we assume the N24 bars, and in the N24 bars we have 4 bars, and we just need to take more than 1517. So if you go back here, 1517, which is 1808, and we can add up 4 bars. So we can use 4 bars of 24 diameter N bars. Actual area is 1808 millimeters square, that is taken from these tables. Now there is a B part, where we need to calculate in the B, where you need to locate where along the span 1/2 of the longitudinal reinforcement can theoretically be terminated. So we just need to just take some notes. MUO we calculated 588 10 to the power 6. That MUO we calculated in the previous video. I can just show it to you. That MUO value that we calculated is a 508 10 to the power 6. That is in the kilonewton, 588 kilonewtons. Now it says that 50% of MUO, so we just need to half, that is given 294 kilonewton meters. Now we do some structure analysis, like it has 8 meter span given in the questions, 800 millimeter span given in the questions. We calculated the design load at the start. From the previous video, we calculated design load 62.4 kilonewton meters, that is uniformly distributed load. So if I convert this uniformly distributed load into the concentric load, that is times by the length, it gives us 500 kilonewton. Reaction force is half, 250 on the east side. Then we can just draw this x distance we need to find for 200 kilonewton for this 62.4 kilonewton per meters. We have this moment 294 kilonewton meters, that is the half moments. In that case, we can solve 250 times x is equal to 294. It gives us x equal to 294 on 250. that give us 1.17. So that distance is 1.17 for 50% of the steel reinforcement on the both side. Thank you very much.